Hi everyone, let's understand this problem. Longest common subsequence. Given two strings text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters can be none, deleted without changing the relative order of the remaining characters. Okay, for example, AC is a subsequence of A, B, C, D, E. So let's understand the subsequence first. So let's say, for example, if I have this particular string, A can be a subsequence, AB can be a subsequence, AC can be a subsequence, ADE can be subsequence, ACD can be a subsequence. So here if you see, but EDA cannot be a subsequence or DAE cannot be a subsequence because we are missing the ordering of the string. So if you see ADE, we got it by skipping B and C. But if you see E, there is no order in which these characters appear in this particular subsequence. So that is about the subsequence. I hope it is clear. Now what they are saying is like they have given us two strings and we have to find the longest common subsequence length. So if we take these two strings and if you take the ACE in both the strings, that is the longest common subsequence. Now we are going to solve it using dynamic programming and let's see how we can do that. So for that, let me copy those strings here and first let's understand one particular thing, A, B, C, D, E and A, C, E. So let's say this is being pointed by I pointer. Let's say this is being pointed by J pointer. Now in this case, we are checking if both the characters are equal. If both the characters are equal, what will happen in this case is that we just will ensure that we check the remaining longest subsequence in the remaining characters. That is nothing but we are going to increment our I and J. So it will become I plus 1 and J plus 1. Right? That's how we are going to get it. But let's say I'm going to have a character D instead of A. So both of them are not equal and this represents I, this represents J. So one thing can be move my I pointer here. This is nothing but I plus 1 comma J, because there might be a substring or subsequence here in this case where we might find a longest common subsequence in this particular pair. Or the other way could be I keep my I pointer wherever it was and move my J pointer and I find my subsequence in the remaining values of the text2. In this case, we are finding the longest common subsequence in the first text entirely and the next one is nothing but J plus 1. So here it would be I comma J plus 1. So when this is when text 1 of I not equal to text 2 of J. And what are we going to do? We are going to take max value from one of them. But let's say if they are equal instead of not equal, if they are equal, what we were going to do, we were just taking I plus 1 and J plus 1 and whatever is the value there, we are just adding 1 because these characters are already matching. So we are going to draw a grid and understand it even further, but I hope this is clear that how these conditions are playing in. So ACE. So this is nothing but this is the next second string, so it will be J pointing and ABCDE. This is I pointers. So now let's draw it. So now all the values outside of bounds will generally be 0. So this is just for understanding purpose. We were not going to use them for any purpose. Now let's say I kind of start at this position. If you see, E and E are same. So these are represented by I, these are represented by J. So if you see I and J, this particular cell, they are equal. That means we are going to go to I plus 1, J plus 1. So I plus 1 and J plus 1 is nothing but the diagonal cell, which is 0. So it is, the value it is going to return is 0 to us. And since they are equal, we are going to add 1 to it. So the value here is 1. And if you see E and C here, EC, in this case they are not matching. If they are not matching, we are going to check the remaining values. One is on the left, sorry, one is on the right and one is at the bottom. So these are the values which we are getting, and we'll take the maximum of it. So max of 1, 0 will be 1, and we do not have any value in this particular cell, so we will just write 1. And again E and A, they are not matching, and maximum of 1 and 0 will be 1. Now we have D and E. So when we have D and E, again, are they matching? No. We are going to take max of these two, that is nothing but 1. And C and D are not matching. Again, we'll take max of 1, 1, it is 1. A and D are also not matching. So in this case also we are taking max of 1, 1, 1. And now we are in the third row. C and E. C and E are also not matching. So we are taking maximum of 0 and 1 here. And then C and C are matching. So when C and C are matching, we are going to take the diagonal step, and we are, since they are matching, we are going to also add 1 to it. So in this case it is nothing but 1 plus 1, it is nothing but 2. Again, now again we are here, we are checking A and C. A and C are not equal, so we are going to take maximum of 1, 2, the value is 2. B and E are not matching, so we are going to take maximum of bottom and right cell, which is 1. B and C are not matching, we are going to take maximum of bottom and right cell. Bottom has the maximum 2. We are going to check A and B. In this case they are also not matching, we are going to take maximum of this 2. And here in this case E and A, they are not matching, maximum of 0 and 1 will be 1. A and C, they are not matching, we will take maximum of 2 and 1, so it is 2. A and A are matching. In that case, what are we going to do? We are going to take an element from the diagonal, so that is nothing but I plus 1 and J plus 1, and we are going to add our value as 1 because they are matching. So if you see here, we are adding all 1 as well, 3. So the answer will lie in dp of 0, 0. So now let's write the code for this. So the dp array would be array, and first of all let's define length. Let m is equal to text1 dot length. Let n is equals to text2 dot length. So this should be good. Now we are going to define our dp array of m cross n. So this will be m, and then array of n. Initially all of them will be filled with zeros. Then we are going to start at m minus 1, I greater than or equal to 0, I minus minus, and also j is also starting at n minus 1, and j is greater than or equal to 0, and j minus minus. In this case now I will have to compute the values dp of ij, right? If so, I'll have to check if the text is equal to or not. Text 1 we are going to index it with I, so text 1 of I is equals to text 2 of j. That means dp of ij will be 1 plus dp of I plus 1 j plus 1. But here there is a catch. So if you see here, if I am at this particular position, this is nothing but the last index of the row and column as well. So in this case I am going to go out of bounds, so I just need to add the bounds here. So how am I going to add? So if I plus 1 is less than m and n j plus 1 is less than n, then I'm going to return this value, otherwise I'm going to return 0. I hope this is clear. It's very simple and straightforward. Else what am I going to do is dp of ij will be dp of I plus 1 comma j comma dp of I comma j plus 1, max of these two values, but I'm just going to create two different values. Bottom value is nothing but dp of I plus 1 and j, and the right value is dp of I comma j plus 1. Now in this case we also have to add the checks. I plus 1 is less than m. In that case I'll return this, or I'm going to return 0. Same thing here, if j plus 1 is less than n, I'm going to return this value, else I'm going to return 0. Now I will take math dot maximum of bottom value comma right value. Now once this is done, my answer is at dp of 0 comma 0. So in order to avoid all these edge cases, you can also define m plus 1 and n plus 1 array. I'll show the solution as well. So for now let's kind of run this, submit it. So instead of handling all of these edge cases, we can define one more column and one more row, so that we kind of always within the bounds. So let's say I kind of define these values, and instead of, let me remove all of this bound checks. Same thing here, I can just directly get this value here, get this particular value here, and get rid of all of this. So now what will happen is, like, I plus 1 and j plus 1 will never go out of bounds, because we are like defining one safe cells, safe row and safe column, so that the values are always available. Let's run this particular thing now and submit it. So either way works. You can choose whichever you want. Either you want to add boundaries or bound values, or you can declare one extra row and one extra column, up to you. So now the time complexity of this solution is nothing but big of m cross n, and the space complexity is also big of m cross n, because we are like declaring the DP array, which is m cross n. I hope the solution is clear. Thank you.